now let us study about position of a point. So before we get into the position of a point, we must first look at a few standard notations about circle that are important for us to remember. I hope you all remember, for a straight line, y is equals to mx plus c. For a straight line, we used to represent the standard notation with L, and that used to be y minus mx minus c. And we used to represent L1 for, let's say, any known point that used to be x1 comma y1. We used to write it down as y1 minus mx1 minus c. Same thing we will be doing for circles as well. For circles, we know our equation is x square plus y square plus 2gx plus 2fy plus c is equals to 0. So what do we write? The s, we represent the notation by s, and it is written as x square plus y square plus 2gx plus 2fy plus c. That is how we represent s. Now let's say if we were to find out about any point, so that we write down by s1, which is x1 comma y1. So we simply just write down the value of x1 and y1 in place of x and y in the equation, plus 2gx1 plus 2fy1 plus c. So this is how s, s1 are represented. Now this notations would be useful for you while finding out position of points when we are doing conic sections as well, for circles as well. Now there is one more thing that you need to remember, which is t. Now how do we notate on t in terms of x and y and its equation? So generally the conversion lies somewhat like this. X square is converted into x1, where again x1 and y1 is the given point in our question. Y square turns into y1. X turns into x plus x1 by 2. Y turns into y plus y1 by 2. And xy turns into x y1 plus y x1 by 2. So again, these are important notations that you need to remember. This is for t. Again, now why are we learning about t, s and l? This helps us to find out position of points. This helps to find out equation of chords and different things. So let's say if I say that there is a circle and its equation of any chord is t is equals to 0. So how can we write down the equation of that circle? Since the equation of circle is written as x square plus y square plus 2gx plus 2fy plus c is equals to 0. So t for a circle would be written as, since x square is there, we convert it into x1, plus y square is there, it turns into y1, plus 2g x turns into x plus x1 by 2, plus 2f, y turns into y plus y1 by 2, plus c is equals to 0. So sorry, not 0, plus c. So this is how t of a circle is represented. Now let's say if I was to represent the t of a straight line, it would be represented as y would transform into y plus y1 by 2 minus m. X would be represented as x plus x1 by 2 minus c. So again, this you have to remember it, how the conversion in a t equation basically works. It is generally the equation of a line. You can see that there are only a single degree term of x and y in the entire equation for circle as well as straight line. So it is a equation of a line. Now it is generally used to represent either chords or tangents or something like that. We will look at that further in the questions and learning while further concepts as well. So these are things that you need to remember. This would be helpful for you. Again, not helpful, this is an important thing that you need to remember. There are a lot of questions that are asked based on these concepts. Now again, there is a very long derivation for this, which is in the syllabus of JEE Advanced. Again, the ones focusing on JEE Mains need not look into all these derivations. You just need to remember this so that you can simply use the formula and find out the answer. So now let us look at how the position of a point of a circle can you find out with respect to a circle. Let's say a circle has been given. So we know that a point P, let us say a point P x1 comma y1, it can lie either inside the circle P can lie either on the circle or P can lie outside the circle. So how are we going to find out whether P is inside, on, or outside the circle? This is outside, this is on the circle, and this is inside. Of course, we know the point has been given to us. It is a known point x1 comma y1. So what do we do is we find out S1 for the circle. I hope you all remember how can we find out S1. It is using this formula. X1 is square plus y1 square plus 2g x1 plus 2fy1 plus c. Once we found out S1, if S1, again it is a constant, so if it is less than 0, point lies inside the circle. If S1 is equal to 0, it lies on the circle, and if S1 is greater than 0, it lies outside the circle. A very important thing, a very, very important thing that you must remember. You will be seeing that we are doing using these formulas in parabola, ellipse, and hyperbola as well. So this is a very important thing that you need to remember about S1, S, T, L1, and L. So again, whenever a point lies on the equation of a circle, we know that that point would satisfy that equation. That means S1, which is the, basically S is the entire equation of the circle. If this is equal to 0 and it satisfies, any point satisfies this equation, that means that point is lying on the circle. So that is how we get S1. About inside and outside, of course, these are things that you need to remember. If it is inside, it would be less than 0, and if it is outside, it would be greater than 0. Now let us look at the position of a line. Of course, let's say this is a circle. The line can be either here, the line can be either here, the line can be either here. So let me draw this line more specifically. So either it can touch the circle on one point, or it can intersect the circle at 2 points, or it may neither intersect nor touch the circle. So this is outside, this is our tangent. I hope you all remember, whenever a line touches the circle at one single point, it is known as a tangent, and whenever it intersects, it is known as a chord. So how can we find out? Of course, the equation of our line has been given to us, y is equals to mx plus c, and the equation of our circle has been also provided to us. Let's say x square plus y square is equals to r square. Let us take the general form. So of course, how can we write down the s for this equation? It is x square plus y square minus r square. Now again, this was just to tell you, of course, s has no use here. But now how can we find out the position of this line? If I put the equation of this straight line and this circle together, and I try to make a quadratic, let's say if I put the value of y, mx plus c, in this equation, what would I get? X square plus mx plus c whole square is equals to r square. I'm getting a quadratic in terms of x, quadratic in terms of x. Now of course, I hope you all remember, whenever x used to come out positive, let's say the both values of x, if they used to be positive, or whenever we used to find out the discriminant, that used to be b square minus 4ac. Upon solving this quadratic equation, if we take it into a standard form, which is our ax square plus bx plus c is equals to 0, and we find out the discriminant, if our discriminant comes out to be less than 0, that means the equation does not have any real roots, it has only imaginary roots. That means we can say that this straight line does not intersect the circle, it is intersecting the circle at some imaginary point which we are not able to find out. So, and if d is equal to 0, we know it is a tangent, that means there would be one single root, and that one single root would be the one point that we are getting. And if d is greater than 0, we would be getting two real roots of x, that means it is intersecting at two equal points. So from here we can find out whether the line lies outside, entirely outside the circle, or it lies as a tangent to the circle, or it lies as a chord to the circle. So this is how we find out the position of our straight line with respect to a circle. Again, an important thing you need to remember. Of course, there is another way as well of finding out the position of a line. So this was the most basic one. Of course, here also it mentions the same thing. If d is less than 0, line does not intersect. If d is equal to 0, line just touches the circle at one point. And if d is greater than 0, it intersects the circle at two different points. So here we have 1 point and here we have 2 points. Now for a circle, you know the radius of the circle, which is r. Now if a line is, let's say, a chord, that means if you find out the perpendicular distance from the center, let's say this is d. If you find out d and it is less than r, that means it is a chord. And if you find out d to be equal to r, let's say this is our line. If you find out the perpendicular distance d and it comes out to be equal to r, that means you can say it is a tangent. And if it is outside, that means d is greater than r, then it is of course nothing, neither a tangent nor a chord. So this is another way of finding out the position of a line with respect to a circle. However, this shortcut concept can be applied only in circles only. So you must remember this discriminant concept as well, because when we are studying parabola, ellipse, hyperbola, there is no shortcut ways for you to find out the position of a line. You have to use this discriminant formula only, where you have to satisfy or put the value of any one of the variables in the equation of the other in the other equation of the circle, and then make a quadratic, find out the discriminant and check according to the value of discriminant whether it is negative, 0 or positive, whether the line lies outside the circle, whether it is a tangent or it is a chord. So important concepts that you need to remember about point, line. Now let us try to learn about this distance between point and a circle. So let's say a circle has been given. There are two things that you can find out about a given point: either the maximum distance from a circle or the minimum distance from a circle. So of course, if let's say a point is lying here, let's say if point is lying here, what would be the minimum distance from the circle? This would be our minimum distance. Let's say this point is P, this intersects this at M. We draw a straight line into the circle. Now of course we can make out that the other point would be lying of course in the center as well, C, H comma K, and the other point is, let's say A. Of course the point which is at the farthest distance would be on the opposite side of the diameter, because the diameter is the longest pathway in a circle. So from here we can say that the maximum distance from the circle is AM plus MP, and minimum distance is simply just MP, and AM is nothing but 2R. I hope you are understanding how we are getting this thing. So again, there isn't any much concepts that you need to understand here. This is simply just logic based. Again, I'm telling you so that it becomes easier for you to solve questions. Whenever there is a known point given to you, x1 comma y1, and you have to find out the maximum or minimum distance of that point from the circle, you can simply find out the diameter, the straight line, which is the diameter of the circle that passes through this point as well. And once you've found that, you can find out the nearest point as well as the farthest point as well. It would be calculated as per this formula, MP plus AM, and minimum distance would be just MP. Now let us talk about position of two circles. Now I hope you all understand that two circles can either be far away from each other, they can either be touching each other, intersecting, or they can be inside each other, or so there can be a lot of ways. So let us see how we can find out those. Let's say first one, let's take a circle has been given to you, another circle has been given to you. C2 is the center and C1 is the center of first circle. Again, the centers have been defined. You know the position, you know the coordinates of the center, and you know the radius as well. This is R2, this is R1. Now let's say these two circles are far away from each other. So if I find out, let's say C1, C2, the distance between C1, C2, if it is greater than R1 plus R2, That means I can say that the circles are farther away from each other. They do not intersect. They are very far from each other. So this is like one of the ways of finding out position. If let's say the two circles are touching each other, then I can say that if this is C1, this is C2, this is R2, this is R1. So what can I say? C1, C2, which is the distance between the centers. This would be equal to R1 plus R2. This is another way of looking at the positions. Of course, important things that you need to remember. If let's say the circles are intersecting with each other, so what can I comment? I can say that C1, C2, I can say that C1, C2 is less than R1 plus R2. Of course, you can see that the distance between C1, C2 is less than R1 plus R2. And it is greater than R1 minus R2 modulus. Now, why I am doing this, we will understand about R1 minus R2 in the later positions. Now, let's say if my circle lies somewhere inside this circle, what is my R1 minus R2? I hope you are understanding about R1 minus R2. Let's look at here. Let's say if this is my circle, this is my R1 and minus R2. Let's say R2 is my smaller circle. Its diameter is here. That means the distance which is from the center to this point, that would be R1 minus R2. This distance is basically what we are referring to R1 minus R2 mod. Of course, we do not know whether R1 is greater or R2 is greater. So we are just, for the timing, we are putting it inside modulus so that we get the absolute value here. Now let's say if a circle lies inside this circle and it touches this circle this way. So we know this one is C1, this one is C2, this is our R2 and this is our R1. Or I can say that this distance is also R1, this distance here. So if my C1, C2 is equal to modulus of R1 minus R2, that means this is my case. My circle lies inside, one of the circle lies inside the other circle and it touches the circle from the inside. And from here, what else I can comment? That R1 is equal to 2R2, because the entire diameter of the smaller circle gets fitted into the radius of the bigger circle. So these are things that I can comment on. And let's say if there is a circle and if it lies somewhere just inside, so we can say that C1, C2 is less than modulus of R1 minus R2. Now for here, we cannot comment on R1 and R2 as well. So of course, R1 would be greater than 2R2 for this case. So again, these are some cases that you need to remember by heart. There are a lot of questions that are asked based on this. Again, the same things have been mentioned here. Let's say if D, again, D is nothing but C1, C2. The distance between the centers of two circles, if they are separate circles, then this is D would be greater than R1 plus R2. If they are externally tangent circles, that means they are touching each other. Intersecting circles means they are intersecting at some point. Internally tangent, that means one circle is bigger and the other one touches it internally. One circle inside the other, that means they are not touching at all, however one is inside the other circle. And concentric circles, we know concentric circles are nothing but circles having the same center. Of course, the radius of one is greater than the radius of other. So that is when we represent concentric circles. So important concepts you needed to remember. Now we will be looking into the equation of chords and all. Now when we are looking into the equation of chords and different tangents as well, the T equation that we had studied in the first standard notation, that will be of major use there. So remember this concept. If you were not being able to understand T concept, I would recommend you to watch the video again, but clear your concepts about T, S, S1, L and L1. It would be very helpful for you while finding out positions and chords of any conic section or any coordinate geometry shape that we study.